In this video, we are going to see Unit 5 Laplace transform. In Laplace transform, we are divided into two. One is Laplace transform, another one is inverse Laplace transform. Now let us see some technical terms. First one is transformation. What is transformation? It converts one form to another form. And second one is periodic function. It means it repeats its values in regular intervals. Now let us see some application of Laplace transform. Application of Laplace transform is used to simplify calculations in system modeling where large differential equations are used. In electrical circuits, a Laplace transform is used for the analysis of linear time invariant systems. Now let us see the definition of Laplace transform. L of f of t equal to integral 0 to infinity e power minus st f of t into dt. So it will be equivalent to capital F of s. So this s is a parameter and t is a time domain. Therefore, the definition of Laplace transform is L of f of t equal to integral 0 to infinity e power minus st f of t dt. Now let us see some sufficient conditions for Laplace transform. There are two conditions. One is f of t is continuous on closed interval a comma b where a and b are greater than 0, and the second one is it is an exponential order. Now let us see some formula of Laplace transform. L of 1 is equal to 1 by s, L of k equal to k by s, L of t power n is equal to n factorial by s power n plus 1, L of e power at equal to 1 by s minus a, L of e power minus at equal to 1 by s plus a, L of sin at equal to a by s square plus a square, L of cos at equal to s by s square plus a square, L of sin h at equal to a by s square minus a square, L of cos h at equal to s by s square minus a square. Then L of t sin at equal to 2sa divided by s square plus a square the whole square, L of t cos at equal to s square minus a square divided by s square plus a square the whole square. By using these formulas, we are going to see some problems. Now let us see some problems by using Laplace transform formula. Now first problem is you have to find the Laplace transform for e power minus 60. By using the definition of Laplace transform, L of f of t equal to integral 0 to infinity e power minus st f of t into dt. Now in this problem, our function f of t is e power minus 60. So you can replace this f of t as e power minus 60 here. So if you replace, finally you are getting this equation. Base are same, you can add the powers. So you are getting this a form. Now integral this function. The integral formula for this function is integral e power ax dx. So integral e power ax dx is e power ax by a. So by integrating this function, you are getting minus e power minus of s plus 6 into t divided by s plus 6 with the limit 0 to infinity. Now you have to apply the limit, upper limit, then lower limit. So first you have to apply the upper limit as t equal to infinity. So e power minus infinity is 0. Then you have to give the lower limit as t equal to 0. E power 0 value is 1. Lower limit 1 minus, and here 1 minus getting plus. So final answer is 1 by s plus 6. Then second problem, you have to find a function t plus 1 the whole square. For this t plus 1 the whole square, you have to find Laplace transform. Now you have to expand this t plus 1 the whole square in a form of a plus b the whole square. So that is t square plus 1 plus 2t. Now you have to split the Laplace transform. That is L of t square plus L of 1 plus 2 into L of t. This 2 is constant, so we are taking outside from the function. By using that formula of L of t power n, here n is equal to 2. So the formula of L of t power n is n factorial by s power n plus 1. So from that you are getting 2 factorial by s power 2 plus 1. Then L of 1 formula is 1 by s. Then L of t formula is 1 by s plus 1. From that you are getting a solution as 2 factorial is 2 divided by s cube. Then 1 by s plus 2 by s plus 1. Next we are going to see Laplace transform for the function cos 2t. By using the formula of L of cos at is s by s square plus a square. Here in this function you have a equal to 2. By using the definition, L of cos 2t equal to s by s square plus 4. Then the next problem is you have to find Laplace transform for sin h 3t. By using the formula L of sin h at equal to a by s square minus a square. In your function a is 3. So you can replace, from that you are getting 3 by s square minus 9. And the second next problem is Laplace transform for cos square t. So cos square t is rewritten as 1 by cos 2t divided by 2. This 1 by 2 is constant, so you can take the constant from the Laplace transform function. So from that you are getting 1 by 2 into Laplace transform of 1 plus Laplace transform of cos 2t. What is the formula of L of 1? That is 1 by s. L of cos 2t is s by s square plus 4. Now let us see some properties of Laplace transform. First one is L of a f of t plus or minus b g of t. Here a and b are constants. From that we can take the constant term as outside. Finally you are getting a into Laplace transform of f of t plus or minus b into Laplace transform of g of t. Then the second property is change of scale property. The statement of change of scale property is Laplace transform of f of t equal to capital F of s. From that we are getting L of f of t equal to 1 by a into capital F of s by a. Then the third property is shifting theorem. Here there are two types of shifting theorem. The statement of shifting theorem is if L of f of t equal to f of s, then the first condition is Laplace transform of e power minus at into t equal to capital F of s plus a. The second condition is Laplace transform of e power at into f of t equal to capital F of s minus a. Then the fourth property is Laplace transform of derivative. The statement is if L of f of t equal to capital F of s, then L of f dash of t equal to s into L of f of t minus f of 0. Then fifth property is Laplace transform of integral. The statement is if L of f of t equal to capital F of s, then Laplace transform of integral 0 to t f of t dt is equivalent to Laplace transform of f of t divided by s. This L of f of t is rewritten as f of s divided by s. Then the sixth property is derivative of Laplace transform. The statement is if L of f of t equal to f of s, then L of t f of t equal to minus d by ds into capital F of s. In general we can write Laplace transform of t power n into f of t equal to minus 1 whole power n into d power n divided by ds power n into capital F of s. The seventh property is integral of Laplace transform. The statement of this, if L of f of t equal to f of s, then Laplace transform of f of t divided by t equal to integral s to infinity f of s ds.